good search.
Yeah, definitely.
Yeah, it was good. Did somebody called you out and made you talk about it?
It's a bit of a hobby, though, to be honest.
We spoke about that last December. Yeah, in Charlotte. Yeah, right. Okay, let's get back together. We'll get a few questions and answers, and then we'll start the final panel for the day. We get to choose a table, maybe over here on the left. Looks like Adam. Adam, who do you nominate? Adam Martin. Who do you nominate for your table? Not him either? All right.
Okay, we were free associating on all the various problems that we were hearing, both based on Yolanda's presentation and just our personal experiences here. So our list of kind of problems that need to be focused on or thought about include communicating to and educating users on the knowns and unknowns within the models that we're using. And this kind of spoke to Yolanda's ontology of models and how communicating knowns and unknowns should be somehow part of that. Communicating uncertainty and margins of error that can be easily propagated throughout workflows, is a key issue that comes up in the work of folks here. Help, as these models and methods become more democratized, how do we ensure a suitability for particular data sets or situations? And does that require domain expertise or methodological expertise? And so at least from a methods perspective, maybe you can help identify suitability of models based on the data that you're bringing to the table and just avoiding common problems like overfitting. Some of another challenge around that came up when we're thinking about autonomous vehicles is, knowing when you're working with interpolated data versus extrapolated data from models. I won't expand on that because I don't understand as much. And then just concerns about knowing when your samples are representative and making sure that there are ways to check that. Just I think validating that concern that was voiced in the panel.
Cool. Sounds like a good reflection of a lot of models discussion. Who's next? Andre, you're going to be the spokesperson? I was told there's a willing participant.
So we, I, that's right. So I made the argument that AI is a social construct, not because I think so, but because our analysis showed so. So one of our projects recently, we did a domain language analysis of more than 100,000 documents in data science and analytics. And it clearly showed that machine learning is real. It is a set of technologies. Deep learning is real. CNNs are real. AI is a social construct, is a societal construct. It's not a set of technologies. Now, there are other indications of that, like one recent study of European companies showed that at least 40% of those that say they use AI don't. And even that is probably optimistic. Then I think the observation was also that it was a very nice setting here for communication about like what is machine learning, what is deep learning. And I think there's maybe a lack of venues to have exactly the conversations that we had to build that up from how does it work to what are the use cases. Wow. And the third theme was generally knowledge representation. I think where we had a lot of commonalities, the need to basically analyze large. So, and that was one question I had about knowledge-based, whatever the end of that title was. I would have called it model-based.
Oh, for Yolanda Gill's
That's right.
presentation?
That's right.
Yeah, I think she might have done
Because
it, yeah.
knowledge comes in many forms, and was a very limited set of knowledge types that were being used to drive it.
Interesting.
Physics-based model. Okay.
Yeah, oh, yeah, yeah,
Uh,
yeah. She was
as
focused
opposed to
on
the
that.
many other internal and externalized artifacts of human knowledge
Yeah, very
that
fair.
should be used.
Okay.
Did it?
Wow, you guys did great. Cool. Yeah. As we're moving up to the next table, let me do a shout out for Andre, though. He's doing some work for OGC that will be revealed real quickly, a base map for geospatial technology. And so we're looking forward to that we'll put it on the public website, and it'll be really quite a resource for the community to understand these concepts. So I'll look forward to that, Andre. Yeah. Yep. Yeah. Can I ratchet it up, man? Yeah, yeah. Okay, Ajay.
Thanks. We had a good conversation on the table and had a number of things that we thought were interesting in in session 2. One was the quality and source of training data really is a key issue. Also, identifying what the correct, the best, or the good sources of data, both data sets and data sources really are. And we thought it was interesting that the level of confidence in the data and the outcome is related to the application. Some applications need more and some less level of confidence. Model integration and scalability was also of interest. We had a long conversation about that, about how some models may simply not be scalable. And that communication ultimately was the key, broadly, communicating the data to others, to decision makers or end users, the confidence in the data, the models, and the ultimate impact in our analysis. Thank you.
Cool, very good, well done. All right. Table 4, or whatever.
We talked a lot about hype.
Hype?
And
Social constructs and
yeah,
hype, maybe?
so
Yeah.
very similar to that. What, is it, are we at the top of this hype cycle and will we find our way to a little bit more reality? And we talked a lot about that and mixed kind of ideas, but that there's a lot of value. I mean, and part of that led us to a discussion about the fact that we haven't talked much about theory, and that that theory plays a really important role in analysis and perhaps less of a role in data science, and not necessarily making a value judgment about that, but that perhaps there should be more theory at play, particularly in the problems that we're trying to solve in the geospatial context. And we also talked kind of in a related vein about education and what does it mean to build up the next generation of data scientists, and what does a data science program look like, and kind of as an interdisciplinary approach, and what are the foundations of that? What should someone coming out of school with a data science degree know? How do you fill in all those circles in the Venn diagram so that someone gets out with enough knowledge to be a productive data scientist in an organization? And the importance of subject matter expertise and data scientists working with subject matter experts in whatever the field, insurance, healthcare, particularly we were talking about that at our table, but that the role that plays in validating what we're learning, because it's really easy for a data scientist without that subject matter expertise to say here, but the R squared's really high, but the model's garbage.
Therefore, I believe
Yeah,
it.
exactly.
Very good, very good. Yeah. We're going to hear tomorrow, I think, about some plans for how to train all the data scientists. Yes, tomorrow afternoon. So keep that idea in mind. So some tables may not have actually done.
So apparently I've been nominated to speak for our table. We had a couple different topics of discussion. I think one of the big ones, because we had some folks representing space agencies in Europe talking about sort of international standards and data sharing across borders, and just what it takes to create the community will to set standards and make data available, and what some of the political pitfalls might be in making that happen. And then we got into a discussion about, graph query language and kind of probably deep into the weeds of the metadata that are required to make that happen.
Cool. Good discussion. Yeah. No, 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 no. Anybody? So I know that back table was really, go for it.
I didn't work with my table. Sorry. I was enjoying
play
that
well with it.
massage chair outside. Okay.
Out in the hallway.
Well, it was break time, so I took
There you
advantage.
go.
Anyways, I work for the California Public Utilities Commission. It's a state agency in California for people here who aren't local. And we regulate electric utilities, gas, all of rail, telecommunications, and transportation, including Uber, Lyft, and limousine services. So I challenge everybody here in this room of masterminds to do what they can to get at with what this the PhD from Esri said at the local level is where this data is most important and most useful. And it's unfortunate that we don't have the expertise that's in this room, and a lot of the sounds like the private companies are taking advantage of all of this technology. But there really needs to be a connection between private and government, and there are some government agencies that will have, for example, one Esri user or one geospatial expert, I would say, for that agency, but still may not even come from a background of any specific science or engineering, may have just been an analyst who learned how to use the tools. So I challenge you all to think about how you can participate in your local governments, and whether it's your company giving back some way to your, you see, oh, we donated so much money to the food bank. Will donate geospatial expertise,
There you
please,
go. Yeah.
because it's really important. I don't want to alarm anybody, but you would be surprised that even at the for catastrophic events in the state of California, the California Cal OES, they are overwhelmed with the job that they have, and they're trying to get data out for the governor, for the politicians, and for their leaders when there's a catastrophic event, and they don't have time to focus on the actual data or the science. They're just trying to get pictures out and as best they can. And now they're working, thankfully, with the National Guard and Beale Air Force Base, who are using some of their intelligence officers and personnel for situational awareness, and they have some of the expertise, but even they're still learning. And I was talking to this gentleman here who spoke earlier about working with Fish and Wildlife and tracking the elk. That was a research project. You weren't actually being paid for that. Although he did say he has worked for the Air Force and the Navy, but that information or that work isn't transmitting down to the local states. For example, emergency management, where it could be very useful. So anyways, I just want to put it out there to you all to challenge you to think about the local governments where you may or may not be able to fit in and offer your expertise, even if it's on the volunteer basis, even if you call up your local city councilman. Every single county in the state of California has to have an emergency response plan. It's a public document. Anybody can comment and participate in the process. So I would just encourage you all to be thinking about that as well for your local communities. And we're a long ways away from trying to gain the expertise at the local level. I'm just going to be honest. I was shocked that my director actually let me come to this. For example, we have a big data collaborative group at the PUC of employees that are trying to work on data warehousing, storage, analytics, and mapping within the PUC. But it's just a handful of us, and we're pretty much just volunteering, doing that on our own to try to bring technology into the CPUC. So anyways, thank you for listening.
No, good comments. Good comments. Thanks. Back to you. Sure, Stephanie.
companies that are
Data
beginning.
trust, I think you
Data
said.
trust, right. And there's a company called Bright Hive, run out of Chicago. So anyway, it's just a concept I thought I'd throw out right now, and we can talk about it over. one
I
of
was
these
going to
other
point to
breaks
your session tomorrow afternoon to get after kind of what should be the next steps.
for the
And
local data.
focusing on local can be certainly part of the recommendations that go
Exactly,
forward there.
right.
So,
And so getting smart about it. They're not big data. That's why we call it all data. It's,
all data. All data are
the all
good.
data revolution.
Data trust. There you go. There you go. Huh, right here. All
So
right.
we discussed briefly about the very desirable situation of having standardized data that is at a consolidated location or agreed upon location that would be easy to access, which really hits home. We work for Here Technologies, so
Oh,
we've got the
yeah,
vision of
yeah.
the open location platform that we're trying to build out.
Betcha.
And also talked a little bit about the challenge of maintaining a training set of data for content that has a temporal characteristic to it that changes over time, and they need to continuously reannotate and continuously relook at to make sure that you got a representation of ground truth. So
It'll be very important to our transportation discussion tomorrow. Ed from DOT and the like. You guys are going to have a good conversation there.
Hello. I think like there's been a lot of overlap in our discussions from especially the last two comments. I think we started with the discussion of how there are so many domains coming together. There's GIS, there's machine learning, there's data analytics, there's the social concept of AI, and how do we put those things together, and how do we help our local governments, and how does big tech we can throw down money and just get whatever data we want essentially, versus academics who struggle to get data and struggle. And there's a dichotomy there, and like how do we have a data platform where maybe it's easier to share data with select few groups that we want to share data with, and is there a standard licensing that can be used? Maybe this is where OGC can help us, and is
Data
there a place that we
licensing.
can put our data and know that it's safe? And but with that, we talked about uncertainty and like how can we measure that, and how can we push that through our data and with the metadata. And the specific example was given, and sorry Apple Maps, but like everyone's experienced either on Apple, because we're at Google, I won't say Google, hey, you're on this route, it's going to take you 5 minutes less time if you take this other route. And that moment of what do I do? And it's never any faster. And what if there was the suggestion from Ed was like, what if there was an uncertainty associated with that? And just making sure that if there's an 80% chance versus a 20% chance that it's faster, you know what you're going to do. So the overarching I guess theme of our discussion was sharing more, whether it's data or whether it's modeling, but then also making sure that we have an idea of what the quality is, and how stale is your data and how good is your model, and being able to communicate that as well.
Very good. Very good. Did you guys have a group at all, or?
No, we didn't, but can staff make a comment?
Yeah, absolutely.
I was actually, I'm intrigued about a couple of areas. First, again, the issue of uncertainty. How do you explain that in context to the decision maker on the ground, particularly at the local level, that the model is predicted, here's the uncertainty, or here's the reliability of this information? That's huge. And I'm not sure we've even scratched the surface on how to communicate that. And I think that was brought up earlier. The other is bias. New York City has gone through a tremendous activity of understanding bias and machine learning. How do we detect it? How do we manage it? How do we explain it in terms of the decisions that are made from third-party models by local government without really good knowledge of what's behind the machine learning? I think these are really integral contextual issues for the community. And then one of the things I observed with the Houston storms not too long ago is data inundation, model inundation. It's understanding how we organize the response in the appropriate swim lanes. So the first responder gets only the information that he or she needs from someone who is processing upstream just in time. And I don't think we've sorted all of that out as well as a community. Is how do we orchestrate the use of AI models and other activities down to different swim lanes in a response mode? So I just offer up those ideas.
Cool. All right. Seems like we had a productive break and breakout session. Good to hear all that. We're now moving into session 3. And so we're going to talk about a topic we haven't talked about yet. AI and machine learning. I tried so hard. But it's clearly the topic to talk about. So, Jay.
So in this section, I guess we have a rapporteur in Yansuk Kim. And bonjour, everyone. So we're going French this time for this section. This is Philippe. And Philippe is the CEO of Topio Networks and Spoke Software. He focuses on building market intelligence platform dedicated to tracking innovation. He spent 16 years at a venture cap in Europe, and then in the US, focused on information technology, specializes in AI, mobility, and smart cities, authoring or co-authoring landscape describing these industries, frequent speaker at industry conferences. Topics are usually smart city and mobility, but he's going to talk about AI
About AI this time,
at the
yeah.
edge. Go for it,
Exactly.
Philippe.
Exactly. Thank you so much for having me. I mean, it feels like having spent the day with you, it feels like you're actually in the trenches, building those models, building, gathering all that data and making it real, right? I'm on the other side, so I'm talking to customers and I'm trying to understand where is the innovation happening, what are the use cases that are really driving adoption, and what are the verticals that are actually driving adoption. And so what I'm going to do today is we are about to release a set of surveys with 2 of our customers, Twilio and Influx Data. And so I'm going to give you a preview of that. So please don't, if you see it, don't tweet it, don't use LinkedIn with it, because I'm gonna be in trouble with my customers. And so what we're gonna do is we're gonna see, where is actually IoT and edge happening, and therefore where is AI gonna happen in the next future. So very quickly, we started in 2015. So we're 4-year-old. We're focused on the business of connected things. We started with wearables at the very beginning, and then we moved into IoT as wearables became IoT. And then we're now focused on edge computing. And the very big next step, which is distributed apps. So in the same way, so I mean, you'll see, right? So cloud edge computing is going to enable a completely different set of applications, and so SaaS is going to move towards more of a distributed concept, distributed apps. And so you need to think, when you're building apps, you need to think about how those apps are going to be built for the future and not for the past, right? So think about SaaS, think about the apps, distributed apps, and not SaaS anymore. And so that's what we're tracking right now. We have about 1.2 million subscribers on our platform, and what we do is we a little bit like wave, right? So a wave in the ocean looks the same across the ocean, but now when it comes to a beach, so for some beach it's going to be a big beach, a big wave. Another beach is going to be a small wave. And so what we do is we understand the same thing for innovation. So we identify the emerging trends, we map timing, we map the critical touch points and opportunities. We then create industry landscapes. So we'd love to have your landscape on geospatial. And we develop and nurture the impacted communities. That's where we have 1.2 million subscribers. And then we enable companies and expert voices to contribute content to the story. And with that, we enable entrepreneurs, startups, but also big companies like Microsoft, Twilio, Influx, to really understand how they can catch the next technology wave. What is the use case? What is the verticals? And how do you go after those verticals? And we do that. We have about now 15 customers and 1.2 million subscribers. And so this is the agenda, right? So I'm going to give you a quick review of the AI market. Then we are going to look at AI for edge at a glance. And then we're going to talk about AI moving forward at the edge, a few observations, and then we'll do Q&A. And hopefully we can, I think it's going to be a nice segue to the panel. And we're going to have a more interesting conversation on the subject. And so very quickly, I think this slide said it all, right? So 60 billion in 10 years. It took 20 years to get to 60 billion for cloud. That's the level of excitement people have for artificial intelligence. And maybe it's deep learning, right? The term that we're using is AI. So that's the level of excitement that AI has in the industry. And the reason is encapsulated in that slide, right? So if you take the CIOs of the big companies, 40% of the top performers think that AI is going to be a game changer for the industry. That's 4 times what the people think about the cloud. That's 6 times what people think about mobile. Just to give you a sense of how important that is for the industry as a whole, right? So people are seeing that AI is a game changer. So yes, there are issues of privacy. There are a lot of issues associated with it, but people are ready to get anything that is artificial intelligence in the marketplace right now, today. So the issue is not about whether there is demand. The issue is, can we fulfill that demand? Is there an infrastructure? Is there a set of tools? Is there a set of technology that enables you to really capture that demand? And so if you look at, and I understand it may be a little bit too small, but if you look at where AI is actually implemented right now, so 1 in 10 enterprise now use 10 or more AI applications. That's the Gartner study. That the big AI, and again, right? So the big AI application was fraud, and now fraud has been caught up with chatbots, with a lot of process optimization, so a lot of industrial Internet stuff, and so that's where we are today, right? And so now, if we look at the other side, which is where is AI on edge, right? So this is the first results of the survey we did with Influx Data, and it's validated completely by the one video. Is we are very early. We are very, very early. So people thought that IoT was happening in 2016, 2016, 2017. We are not even close. Right now, in order for the infrastructure, in order for a user of IoT solution to actually implement them, they need the infrastructure to be in place. And as you can see, right, even for OEM manufacturer, device manufacturer, you're still having only 31% of the people that are actually implementing connected objects. So in order for the wave to really catch up, the device needs to be connected. And right now, there is a lot of data. There is a lot of data available, but in order for this to become very successful, there is a need for even more data. And that's where you see, right? So the customers, the user of IoT solution, are only implemented 10%. Are only implemented at 10%, so very small, right? And so if you look now, the good news is that if you look now at the rhythm of adoption, what you can see is that in terms of number of projects started, right? So that means that people developing applications, you can see that there is about 80% of device manufacturer, IoT solution provider who are happening, and then you can see that since 2018 that the end users are catching up as well. So what that means is, I think I missed one slide. Sorry about that. So what that means is that what we're expecting is by 2021, 2022, because it takes about 18 months to 2 years to implement an IoT project. By 2021, 2022, we should be in a situation where you see an uptick. Both, so all the IoT solution providers, device manufacturer, and OEM manufacturer are going to be equipped, and then you're going to see the end user catching up. So you're going to see a big uptick in 2 to 3 years from now. So still some time to go, but there is nothing in our studies that shows that it's not going to happen. That it's just a matter of of the maturity of the project. So now, if you look at kind of the data, right? So what are the data that are being collected today, right? So what's interesting is that it's a mix of things that people are collecting. So of course, the data itself is about 66%, but video, people are collecting 33% of the projects that are being started, includes video, 28% include text, and 24% include audio. So you're seeing more than data being collected, and 75% of the data is actually time series. And then, of course, you know, I mean, we've been talking about quality of data. We've been talking about accuracy, and the accuracy is going to depend on the type of application that you're going after. So the first one is descriptive analytics, right? So if you're looking at just being able to describe with the environment, the level of the quality of data may be a little bit different than if you're doing the diagnostics. Or if you're trying to predict what's going to happen in the future, or if you're trying to prescribe something, just say, hey, if that's happening, then you should do this, right? So if you're looking at prescriptive analytics, that's where you need the best quality and the best work. And you know, if you're looking at descriptive analytics, you may be able to cut corner there. So again, right, so when you're looking at implementing solutions, you know, start with the descriptive and going back up and build the strengths. Right, instead of starting with prescriptive and then going back down, because prescriptive is probably the hardest. So these are kind of the key use cases that we're seeing at the edge. I mean, there is nothing like that you're going to say is crazy. They are the one that you should be thinking about. And then here is kind of where these are the verticals that are where projects are being started. So if you look at these are the total number of projects that are being started. So consumer has a lot of projects that are being started. Manufacturing has a lot of projects that are being started. Healthcare has a lot of projects. Transportation. Now, if you look at the projects, so this line is gray line, right? But now, if you look at the pilots and then the projects that are being launched, transportation is the place where a lot is happening at this point, and healthcare is a little bit less. So you have a lot of projects that are started, but not a lot of. So it's very early. So there is some discrepancy around where the industry is at, and so. I mean, I realize I may be going fast. Is that okay? I mean, and can you hear me? Is it great? Okay. And so now, if you look at industry, right? So if you look at the state of maturity of each industry and the number of projects that have been launched in those industries, so oil and gas is the biggest one. As the most project launch, agriculture is the second one, utility is the third one, transportation, and then telecom, manufacturing, right? So you see consumer, they have a lot of projects that are being started as a whole, but they don't have a lot of projects that have been launched in the marketplace yet. Compared to oil and gas, which is the other way around. They don't have a lot of projects started total overall because they're a smaller industry, but they are very advanced in terms of implementing those projects. I know there is Omnisci. I mean, does that make sense in terms of what you're seeing as well in the industry? Is there any people that are no? Okay. So now use case. The best use case for implementing edge computing type technology, smart building. 45% of the projects include a smart building component. The second one is environmental monitoring detection with 31%. And the third one is, so the next three is about mobility. So, and if you are aggregating all them up, mobility is actually bigger than smart building. So if you look at kind of the use case, right? Fleet management, connected vehicle, intelligent transportation, and then smart building. So now switching so if you're looking at it, right, it's very early, a pickup in 2021, 2022. You know, very use case and verticals are very. You have a lot of activity, a lot of excitement going in certain places, but there are other places that are actually implementing IoT and being real about IoT. And then the use cases are very you know, straightforward, right? So smart buildings, you know, connected cars. Those are the use cases that people are implementing. And so moving forward, what's going to happen, right? So what's going to happen is massive amount of data is being created today, right? So we're talking about 10 terabytes of data, 4 terabytes of data, airlines 2.5 terabytes of data. So it creates new requirements, and then new requirements are emerging. So the new requirements we've talked about, right? So bias, so the data security, data privacy, compliance. Then bandwidth constraint. So when you're sending massive amount of data through the network, connectivity becomes an issue. And the major points that you're going to see in the survey is that connectivity cost is actually the most important question for an IoT implementation. And then latency, right? So, you know, do you have access to the data that you need? And so if you look at it, so that requires a new infrastructure. And so if you look at the current infrastructure, so that's the infrastructure of the cloud, right? So you have the connected things here, the smart networks, smart cloud, the smart data layer, and then the apps, right? And so what happened is you send data to the networks send data to the cloud aggregates the data, and the data is being mined on the smart data, and then insights are being sent to the car, to the apps, and to the enterprise apps. And so then insights are being sent to the smart data, and so you get to a point where you have data that are basically going from one place to the other. So that's kind of the cloud model. The edge model is a little bit different. So the edge now becomes the center of the place, right? So edge device and premise are the center. Then you have the edge infrastructure, the edge infrastructure, which was, you know, the smart network, and then all the other organize themselves around it. And so what happened here is, I'm gonna not talk about that. What happens is the edge process the data, creates the insights. The insights is being sent to the consumer apps, and then the edge send also anomaly to the edge infrastructure. The anomaly is sent to the cloud, and then the cloud creates sends the information to the smart data, and smart data process the anomaly and create update to the software, which is then sent to the device, right? So it's a completely different model where the data is being processed at the edge, and only a certain amount of data, the anomalies, are being sent to the smart data layer that is located in the cloud. And so so it looked like this. And so now, if you look at, so now you're going to have this new infrastructure, right? So if you look at what are the key points for that infrastructure, the first one is, where do you store the data? Where do you process the data, right? So data storage is a big point. The second one is the models, right? And so including this concept of a digital twin, right? So you're gonna create this digital representation of entire cities, entire manufacturing capabilities, and the information is going to be stored everywhere, and so you're going to have to know where is information needed in order for me to have in order for me to process information about that specific thing, right? And then, of course, the cost, right? So we've talked about the cost, and the other thing is we need cheaper, smaller, and more efficient hardware in order to build that infrastructure. So now, what are kind of some of the key blockers? And I know we're going to talk about that a little bit more during the panel. So it's a way to introduce the panel. So one of the key blockers is access to data, as we discussed, right? The data is still there is data, that is available today, but it's not the entire data set. The second thing that people are talking about in terms of things that are blocking them is the lack of talent. There is not enough talent. So, university, please, train as many data scientists as you can. The infrastructure is not ready as well. And then the last thing is, of course, ethics and principle and biases associated with that. I think we need to come up with, for this specific one, I think we need to come up with some type of a Turing principle, right, where we would compare the bias that humans have compared to the bias that AI have, because right now we're comparing AI to an absolute standard, and that's not. I don't think that's appropriate, right? So we need to come up with way to think about things. And so that's kind of my last slide. So I was able to do this in 15 minutes. So I realized pretty fast. Thank you. Yes.
Any questions for Philippe?
There was one question. Was it?
So some people have started to refer to as IoT as standing for the Internet of Threats.
Yep.
And so we host an annual meeting of the managed security services industry. And we had a room about this size of professionals in cybersecurity. And we asked, knowing what the answer would be, how many of them have connected devices at home, Nest, Alexa, whatever. And it was 0%. In fact, they were laughing that we would even suggest that they might. So in the blockers and the slowdown of adoption, where does cybersecurity play in that?
So two things. So the answer is yes, absolutely, and that's one of the reasons why industrial internet and manufacturing has not taken up, is because people are worried about connecting their infrastructure to the internet, which they've never done. So few things. One is there are already. I mean, there are people working on the subject, right? So the subject is device to the internet, right? So that piece is not secure yet. So people are working on that, and there are already solutions that are emerging, right? So it's something that people are working on, and there are solutions that are coming up. So that's the first thing. And the second one is something that I did not mention is on device, on premise is going to be 70% of implementation. So cloud, IoT implementation that includes cloud is only going to be 30% of the total implementation. So people are gonna isolate themselves from the internet in order to not have the cyber security, right? So that's another way to solve the problem, is to not have to deal with the problem. So right? So those are the two things that are kind of you wanna think about security. Any other question?
Can you clarify? So you said 70% are
We got some people
on-premise deployment.
Yes.
I mean, we're sitting at Google right now, and Google Cloud is pushing things and stuff like that. So where does that number coming from, and where do you think that's going to switch from on-premise to potentially cloud, and when's that time be?
So I think we are. So the pendulum is on its way back. So if you think about what people are doing, like AWS and Microsoft, right? So they are basically pushing their infrastructure down to the edge. So Amazon has an entire infrastructure close to the edge, right? In order to because more and more people are looking at the cloud computing as being too expensive, having privacy and security issue. And so they are looking at other solution, and the other solution is on-premise. And so today, as of today, if you look at the number of the projects that are being started in IoT, so out of 100 projects, 30% include a cloud component, 70% don't include a cloud component.
And remember before I was saying, I think it's 1,000 times. And even if we could do it, we can't get all the data. You know, if you know, just think about it, there's 5,000 games in a day, and then you multiply that by 2.5 hours, and you have that at 4K. Just the cost of getting that in, let alone what you do with it once it's in, it's not a guaranteed network to get it into the cloud, and so there's no scenario by which we can even just get the data to where it would need to go from a distributed global, you know, sense. So it means the cloud generally is off limits until all of our analytics and all of our kind of aggregate. I think I saw that chart before where you know, this kind of U-shaped chart, our aggregate analytics and statistics and everything, that's all in the cloud. So what we can do, we do, but there's a tremendous amount of stuff that I think the cloud is just not there yet.
I think you need to think about the world, right? So the world as we saw it, right? Like one global internet is not. I mean, it's not the world we're going to live in. We're going to live in the next 1 year. I mean, you're going to see a fragmented internet. You're going to see Europe, right? You're going to see US. You've already seen China, right? And so you're going to see that going down, even with enterprise, where enterprise are going to want to control as much as they can. So I mean, this notion of the cloud being this thing is something of the past. I mean, it's not going to be like that in the future. I mean, at least that's kind of my prediction.
Thank you.
You want the panelists to come up, right? Oh, no, you're proceeding
No.
first.
Oh, yeah.
That's good for that. That'll work here.
I have to do something.
If it's not, no, that's not the one. You need a different.
Just plug it in correctly.
I think that's the power. I think you want this.
It should be this one.
It should like, there you
Okay. Before we start the panel discussion, I thought it'd be good to see some thoughts in terms of how we could look at the right trends that are coming about. So I took a few slides from an event. Mark and I were there at Oak Ridge a few weeks ago, where we talked about Geo AI and what it would mean like if you had to handle 100 trillion pixels flowing every few seconds. What kind of architectures emerge? It was sort of like a moonshot kind of discussion. So I thought it'd be good for us as we talk about right trends, you know, just talk about what it means. So I'm Jay. I have been part of software development at Esri for about 26 years. Obviously, you know, like many of you, we've seen the trends come and go. And very often it's the adoption of the trends at different cycles that matter in terms of the value of the trend itself and how you use it. And it's not often that the trend stands all by itself. Very often it's like a tsunami discussion, right? The title was Tsunami, and I was looking up the Wikipedia description of tsunami. Sometimes it's caused by natural things like earthquakes, which cannot be predicted. Sometimes it's by weather, which can be somewhat predicted. Sometimes it's like detonation, which is totally artificial. You know, it just comes up by itself, right? Because you implanted something and you detonate it, right? So I think similarly, we can say trends are also that way. Trends don't stand alone by itself. When you talk about AI and ML, it's not all by itself that the trend is going to show up. So let's just talk about the hype cycle itself. I won't describe what this is because you all know what it is. But the key thing is there's a lot of disillusionment, disappointments, because it's tough to get it right. Okay, that's what we're going through right now. There's a lot of marketing hype with AI and ML. Of course, what is AI versus what is ML, what is DL? That itself is like up for discussion because a lot of folks don't understand the differences. The way I try to categorize is it's okay to be a little loose in some of these terms. It's okay that the term AI exists because AI brings these technical things like ML and DL closer to human understanding. It's trying to say that this is augmented intelligence in a form that humans can understand. That's all it's trying to say. So don't overread the AI aspect of it and try to like map it with something or other that we are more definitive about. Where does data science fit in? I think it's trying to get us out of this trough into being productive. That's where data science comes in. And the tough part is that we have to solve important problems if we need to make this trend useful. And for that, what we need is domain expertise. Without domain expertise, we cannot bypass and make AI come to life in a meaningful way. So if this is the case, how do we go about doing it? So I want to start off with defining spatial data science itself. As organizations, we focus only on one or a few, but not often on pretty much everything else. So if you take spatial data science itself, it starts, like we said, with data engineering. That's the tough part. We talked about spending 70% of the time in trying to massage the data or do data janitorial work as opposed to useful analysis work, right? So data engineering, it starts off with there. And then, of course, you visualize and explore the data. Sometimes you visualize and explore to find out if it's valid data. Is it useful data? Is it data that's got a lot of noise that you have to filter out? And then, of course, you go in and do your spatial analysis. You do the modeling and scripting. You bring it into production. You work with all kinds of data, real-time, big data, and so on. But the last part of collaboration, which is communication, is critical. None of these things of any use if you can't collaborate and communicate. Tell the stories that you found in the process of doing spatial data science. So if you talk about the experience of data science itself, a common way, I'm not saying this is the only way, is notebooks. We talked about it. We had presenters talk about it. But notebooks are a way to experience data science, to do your experiments, to make them repeatable, shareable, and so on. But what do you work with? You work with various spatial analysis tools. You might work with a lot of open libraries that are out there, scientific libraries. And of course, you bring AI and ML into this. So it's sort of like a experiment that you conduct within a notebook. And then when it becomes meaningful, you bring it to production. Now, I want to switch gears a little bit after making that definition on if you need to scale this, bring it to production, make it useful, I want to have a discussion about why the edge matters. So today, if you see, you have all the satellite imagery, the drone imagery, and IoT and everything else going into some cloud, a cloud of your choice. So very often, we're sort of like tied to a cloud, a public cloud, a kind of cloud. And then when you talk about cloud native, it's like, have you made your code native for AWS, native for GCP, native for Azure, fill in the blanks, right? That's how it works today. But it's all going to one place. It's one data center in one region, in one location. And so how much of it can go to one place as opposed to the surface of the earth, not to scale, of course, here, but if you take a city that wants to get all of these coming to life, that's just a tiny place on the earth, and you have a massive surface area to cover. So doesn't it make sense that as you have to cover this surface area, that everything is going local to that place? Now, this might just be like a hypothetical scenario, right? But when it comes down to building AI models, I think this is the way it'll come to production. We can't build global models overnight or within a limited time frame, because what matters is the training. If you need to remove a bias from a model, whether the bias is, can you detect rooftops of buildings, Or can you reduce, let's say, crime in a specific area based on demographics, movement data, and so on? You have a lot of training data within a certain small region. I'll call it the edge that you define as a precinct or as a city or as a state. You train the models there, you deploy the models locally at the edge. Don't attempt to create global models, it'll take forever. Okay. So those are the reasons why we are driving towards the edge as opposed to cloud. Of course, the other reason was latency and the volume of the data and so on. But as we talk about the trend is often defined not just by the physical aspects of things, but also the practical aspects of social acceptance. So that's why I'm bringing this edge case. Similarly, when you do that, not all things are equal at the edge. We have edge devices, everything from our phones, and a lot of these sensors are very smart. I'll just classify them as edge devices as opposed to there are machine-to-machine things, services, I'll say, at the edge, where humans are not interacting at the edge. Okay. Those are things like you have a cell tower that might be edge compute powered that is really responsible for the state of the road in a certain place, so that as cars go by, the sensors on these are getting detected whether there's, let's say, traction available in a certain section or not. It doesn't matter in your overall calculation of going from point A to point B across the state, whether that is happening there. What matters is the other cars that are coming around in that area, what's really going on, and can you give it to them in real time? That's what matters. So the edge in that case is sort of like a machine-to-machine communication at the edge. Then the third case, which I refer to as edge portals, is actually for human interaction. So if you, for example, want the complete experience, a human experience, you don't want to go to the cloud, but you use the models at the edge. You have portals that have built-in models, applications. They tell the end stories at the edge. You don't need to run them in a centralized manner. That doesn't mean that the cloud goes away. It just means that the cloud now extends to the edge. And there are many techniques that are coming in from a software architecture perspective, which tries to abstract that. We're sort of like moving from you're locked down to a public cloud scenario to going multi-cloud and then going to the edge the same way. I can mention one technology, for example, Kubernetes. Kubernetes tries to create an abstract layer where if you write software to that, you can not only run in any cloud of your choice, because all of them have accepted that as a kind of a standard platform, but you can also get it to the edge through KubeEdge. So there are new techniques coming up where you can think of the cloud as infrastructure, and then there's going to be more infrastructure at the edge where the cloud providers themselves will move to the edge, like we are seeing happening. There's Azure Data Box Edge. There's similarly from AWS and so on, all of them moving to the edge because you want to have the receivers also at the edge. The first phase of edge, I would say, we're just responsible for receiving and disseminating. The second phase of the edge, which is really what we refer to as edge computing, is actually executing, getting the job done at the edge itself. And then if it's meaningful, it'll send some aggregated information up to the cloud. And then the cloud is probably getting a global view of the system as opposed to a local view. So if you want to predict what will happen in the next few years, you might go to the cloud and get the answer. If you want to predict something at the edge in 5 seconds, it's not going to go to the cloud and then come back. So here's a few examples. I'll just pick on, let's say, training models. If you want to do batch inferencing, you probably go to the cloud. If you want to do interactive inferencing, you ask at the edge and you get the answers. Because that model at the edge is probably governed better to run at the edge. It's probably more compliant to the local laws of what you can use and what you can't use. That's also the way you address privacy and bias and so on. Because if you're trying to solve a global problem, it's obvious that it's going to take much longer than localizing the problem, right? Similarly, we want workflows to be end-to-end, okay? So when we talk about deep learning and its use in imagery, we have to talk about the full workflow, where you collect the data, you prep the data, you use it for training, and then you build the model, you validate them, and you deploy them. And then once you deploy them, you probably want to run the inferencing at scale. This is the full end-to-end workflow. This typically might happen in the cloud because you want to have the full system in the cloud. This is what probably happens in terms of batch inferencing. Now, how does that come to the edge itself? You pick and choose what you want to do at the edge, and then you deploy it at the edge. You don't do the full end-to-end workflow like you were doing in the cloud. You just bring the ones that are relevant. So for example, you might train the model at the edge because that kind of citizen data may not be able to go to the cloud in a different region or a different country. So you just train the model at the edge and you'll run inferencing at the edge. So there's no privacy law that was broken, and you probably didn't even push that citizen data up to the cloud in the first place. So really what we are seeing is today we have cloud intelligence and we have edge device intelligence. So you can pull out your phones, you can search for your daughter or son's or your spouse's name, and you can get the list of all the photographs, or search by place, search by face, similar faces and so on, right? That's like what I would refer to as edge intelligence on the device. Then you have the cloud intelligence where everything goes up to the cloud, you run the models and you have it there. But there's a huge gap. And this huge gap is because a lot of IoT data that we talk about, whether it's sensor data or data that's collected in so many other ways, it's just wasted today because we don't know what to do with it. Because at the edge, a single piece of data is very important. At the cloud, it's the aggregated that's usually important. You can't keep maintaining that tiny piece of data. So what we need to do is fill this gap, right? I'll refer to that as edge intelligence. So when you do edge intelligence, it's not, again, a black or white. It's a combination. You can do a combination of, like you see here, a device and the edge together doing some training or inferencing. Everything could be done at the edge, or it could be a combination between the edge and the cloud. So it's sort of like a full spectrum. So whenever we have these conversations about, this might be good for this or this might be good for that, what it's really, right, what is coming out of it is really a continuum of architectures that support these cases. So it's, again, not just the cloud or not just the on-prem. It's not in your data center or in the public cloud. It's all of the above that are going. It's just that as humans or as software architects, we tend to focus on wherever the deficiency is. We highlight that and we keep paying attention to that until it becomes the norm, right? So today, I would say, yes, it's accepted that the cloud is serving the needs that it claimed to serve. Of course, like you said, it's expensive and so on. So it's probably meant for some elastic scenarios, some burst scenarios and so on. But if you know exactly what your job size is, it's probably done better elsewhere. So there are combinations of these things that will arise. Again, when we talk about GeoAI, which is using ML techniques with data science, there are many fields that are going to be affected. And when they're affected, think about the impact as things like these converge. 5G, edge computing, and many other things that are probably not listed here. So think about all of these things, because sometimes it's not just one factor that is going to make a difference. It's going to be many. It's like cost versus value, right? Sometimes the cost is significant, the value is very less. But if many things come together, then at larger scale, the value can stay high, but the cost comes down quite a bit. So I'm going to have the panel members make their presentation, starting with Anand. So I'd like to introduce Anand. Anand is a master of many things, I read. That includes process, people, technology management. So just share your secrets. Yes.
What do I do to switch the display? Always a simple solution. Yeah, got it. Thanks. I want everyone to know that I wrote these slides before Todd spoke and Lawrence summarized the tables observations. It's really good. Yeah, exactly. So I already deleted some content, so that should save some time. Um, just to complete the introduction, my day job is managing a bunch of geospatial software engineers. We produce a product. And I happen to, as part of my duties as a fellow in the Tech Accelerate, I work with data modelers, data engineers, and other parts of the organization as well. So some of what I'm going to present here are come from that perspective, right? So I'm not going to go through why the motivation for skill set diversity. We've been through that, but I'm going to focus on the challenge and the opportunity, right? So many universities. My son goes to Waterloo. I have friends in U of T. We hire interns from U of T and Ryerson, University of Toronto, that is. So we have these universities do fantastic job. Like the quality that they produce is very, very good. But in a very narrow sense, many students graduate knowing one of the several disciplines we need to succeed in our jobs. If your job is to build a model that a bank uses for, let's say, customer segmentation, revenue prediction, and things like that, you need a little bit of domain expertise, like Lauren said. But the technology space you need is quite wide. Deep learning, geomatics, SQL, statistics, operations research, GraphDB, big data, this is a subset, right? There are several things you need to know. So the interesting thing, the opportunity for the organization is when you build teams to solve problems, whether it's a software component or a model or a data engineering problem, it's a nice opportunity to deliberately build a team that's diverse talent wise, right? So that's actually a little bit hard for all of us to accept, because we are all too well trained in one thing, and it's kind of not easy not to see the value of something else. I can't count the number of times I've said myself, hey, I've been doing this for 20 years. No, not the same way, right? It's actually quite eye-opening for you to get a new 22-year-old university student come and teach you things that actually the last time I hired an intern, the first thing he said is, the interview went really well. Both of us seem to agree that it's a good relationship. But one of the things he asked is, you're not going to make me program in Java, are you? I said, I fell off my chair. Like, why would you ask that? He goes like, well, my comfort level is Python. I can build Jupyter. It happened to be what I had in mind, but it was still kind of strange that he said that, right? So, um, yeah, so it's important for us to remember that our skills, however proud we are of them, it's like only subset of the tools you have. A good toolsman understands all the tools, what's available. And when you know you're missing some tools, go acquire them. I mean, that's how you enrich your team. I also said it involves learning and unlearning. I mean, the geospatial geeks that I work with, I've been telling all of them saying, hey, I know you're a great Java programmer, but if I ask you to write a code to tell if a picture is a cat or not, how long will it take? There's a university student who can do it in like half an hour. You're using source that already exists elsewhere. So that's justification for us to go out and learn the things that we are missing. And the other thing is unlearning. Once again, not being very quick to say, look, I've already done this. I did this 20 years ago. Like, I say that again and again. I stop myself. It's what is okay? Yeah. It's a mandatory Canadian map. So, so I suddenly realized there's no map, so I had to put it in there. Yeah, very quickly, I'm going to talk about some projects that we thought we did well in machine learning, and I'm going to talk about what's common between them. I'll go bottom up. We actually train neural networks to automate making some map rendering decisions. Typically, when we sell mapping data products, some cartographer sits and like laboriously figures out everything about every layer there is, sets all the thing, it determines the zoom in, and that doesn't scale. I mean, if you go to another country, there are several reasons why all that has to be redone. The data suppliers are different, local cultural setting is different. Even if the map look and feel is identical, the decisions are entirely different. Could we make 80% of that map workspace redundant? So that actually turned out to be, we didn't do it intentionally, but one of the things we did right was we got one of this like interns who were very smart, knew all the tools in the CNN trade, and paired him up with a cartography software engineer specializing in cartographic decisions. That worked beautifully, right? So we didn't set out to do it, but we did it just for skill set at that time. But later we turned out how that uneven hitching worked. So um, likewise, I mean, things like free format address parsing using neural networks. Somebody did the deep learning course in the geocoding team. Said, you know what, like all these if then else conditions I do, that works for 4 countries. And we have like 100 and how many countries, right? So those things don't work very well. Like, I mean, it's case statements, if then else statement, it get very ugly very quickly. So would you let me train these models? Now those models ship as the thing. So it's actually a happy coincidence that somebody actually had the motivation to go something outside the day job, right? Um, likewise, I mean, I'm going to rush through this because I'm taking too much time. So the other is a lot of the decisions we made when we, there was at lunchtime, we we're talking about the points of interest. When a new point of interest comes from a new data source or something like that, for you to say, is this record the same as what I had in other records? We had ugly code like you wouldn't believe, right? All that is now like going through neural networks. It's again, a thing of like somebody who's completely new to the team looking at the problem in a different way. So it's actually, there's a little bit of lesson. So when you make this change, it's not going to be comfortable either for the managers or the business people, right? Managers will need to sign up for deliberately for some setting up some storming in the team. For people who are in the Scrum terminology, know storming, norming, performing, right? So he's throwing his team back, but that's for a good cause. You should sign up for it. Likewise, the business people usually pay a premium for predictability. I mean, whether you're training a model or whether you're actually starting machine learning thing, you're signing up for an iterative thing. So software engineers want to like design the whole thing from end to end, and anything you don't anticipate everything completely, you're a failure, right? It's a completely different mindset for engineers. Likewise for business people as well. Don't project the end. Try to get it, I mean, and be ready to cut it off if it doesn't work, but try not to predict the whole thing. So it's a little bit of training, learning, unlearning involved on everyone's part. That's my perspective. Thank you.
Thanks, Anand. Next is Milan. He's the CTO of Metropolis NVIDIA. He leads the technology and innovation strategy over there and has deep expertise in applying AI to solve various business and scientific challenges. Go ahead, Milan.
I need your help in solving this simple challenge.
Okay, let's try this.
Maybe this.
Is this the pointer? Oh, you have it. It's on this side, yeah.
I think it's just this. There. It's doing. Thank you.
Sure.
Thank you. Good afternoon. I think there were a bunch of things I was going to show you about how cool, sensor data, when it comes together with a system of record data, we can really get insights for multiple domains. But after looking at the slides Jay had, I think that motivation is not needed anymore. So I'll start with a question I know I'm going to get because I'm representing NVIDIA. We are talking about compute, we are talking about compute at the edge, compute in the cloud, and so on and so forth. And this is fresh. I just read this early this morning that OpenAI came up with this study which says that till 2012, that's the era that they are now calling, where it was okay, you could go with Moore's law and the doubling, the 2-year doubling was okay. But they are basically now showing with examples that in just the last 7 years, we are needing more compute. We are needing compute to double every 3 months, 3.5 months. So this is just going to get more demanding. So we know for a fact that a lot of what we also saw earlier about the various use cases, this will translate. So we are going to need more and more AI compute. The hype cycle or no hype cycle, the compute need is definitely increasing. Some of this will come out as products, functioning products when people create these technologies. Some of those will die as data science experiments, but the need for compute is definitely going up. I'm going to skip this because I was going to talk about how my approach to geospatial is more as a user. I know we have seen Jay talk about deep learning technologies to really annotate the environment itself, the underlying map, and enrich the layer, enrich the environment context. But we are looking at it far more from a perspective of marrying the sensor data that we see with the environment data that is coming from a building information model or layers of GIS information of outdoor environments. And when you look at sensor data, it is just, I will just show you with an example. The amount of data, both the volume and the rate at which these data is coming at us is so humongous that, as was discussed earlier, going to the cloud is actually not an option. You have to actually push the processing closer to the data than push the data to the cloud. And this is something that will impact so many other verticals in terms of getting situational awareness. So what we are working on at NVIDIA Metropolis is basically a stack, goes all the way from hardware and software to help developers, AI end-to-end solution developers, build solutions for situational awareness. That's really what the platform is meant for. So just an example, right? We are, this is something we actually are doing. We are already deploying using Kubernetes, what we call the EGX stack. This was just announced by Jensen at the Mobile World Congress in LA a few days ago. And what this stack really does is it basically allows for your workloads to run at the edge. And these workloads can be addressing hefty data like video data. So if you look at the Levi Stadium, I don't know how many of you know, they have 1,000 cameras. If you look at a small city like the one that we are working in Iowa, 5 mile by 5 mile city, it has more than 1,000 cameras. Just imagine, right? That's terabytes of data per day that is being generated. You just don't have the option of sending that data to the cloud. Even if you did, I mean, various issues, privacy, security, but just cost. And that one, some simple question makes the determination for that CIO of the city saying, I can't send this to the cloud. So you have to take the processing to the edge, right? So what we are doing here is we are basically deploying an end-to-end application for traffic monitoring and analytics. Right? And what that does is it actually detects objects. Again, just looking at, if you detect 50 objects per frame, that's 1.5 million messages per second. So all this data is now, I would say this is the sensor plus geospatial, because every object that I detect currently in that frame, by calibrating my camera, I can actually tell you what is the GPS coordinate. So we are actually getting more data from cameras about location information of objects than what you get from, I started large projects at IBM Research, using this data, right? Tower log data and GPS data from apps, etc. But the rate at which even the messages, forget about the pixels, that we are getting by analyzing cameras is just humongous. There are other data sources too, right? Like LiDAR, 3D point cloud, so on and so forth. And we really cannot make sense of all of this if we are just limiting ourselves to the pixel domain, to the image plane. We have to convert this information into the real world map-based understanding of the context to say what's going on. So for example, I don't know how many of you can see this. I wish I had the video with me. This is actually a real anomaly. Nobody was hurt in the making of this video, but this is a real anomaly where a vehicle kept going in the wrong lane, right? And it kept driving in the wrong lane. And we actually ended up detecting it in multiple cameras. This was an experimental system. The city did not have access to these insights, live. But if they had, they could have actually done things in real time, like switching the traffic lights to red, escorting a police vehicle, escorting this vehicle off of the road, so on and so forth. So lives could be saved, right? So in the various things that we talk about in terms of spatio-temporal awareness, situational awareness, insights, some of these, as was discussed, are more global in nature. So we can actually figure out what is the, how does the traffic in a city look like? Although we of course have Google to tell us that anyway. But these kinds of things, such as accidents, anomalies, or optimizing the traffic based on how what kind of vehicles are actually experiencing more time, etc. You have to go to other forms of sensing. And so my main takeaway from this is there is definitely compute coming as close to the data as possible. Now, some people may call it edge, some people may call it fog, different terms. but there is a continuum, and we'll have to actually process it in different places. The other part is the networks. A really good vehicle detection model in the Midwest may look very different than a really good vehicle detection and tracking model in Shanghai or Beijing or Mumbai. So the localization and in fact, I would say creation of bias that makes the accuracy improvements in those particular environments will actually force us to actually have an ensemble of models where we switch between different things. For example, in this city itself, it's already started snowing. We have had 3 snowstorms. So we are anticipating we'll get more data to do detection of vehicles while the snowstorm is on. But there are other use cases, right, where do we still see the road networks, right, or do we see them covered? Has the snow been plowed throughout the city? All these kinds of additional insights the city can continue to get if they have this geospatial situational awareness that marries sensors to location. Um, a second thing that we have done in Metropolis is we have created a small little library called QSpatial. And the purpose of this library is nothing more than GPU acceleration of very, very common spatial operations, right? So we are taking the most commonly used operations, for example, point in polygon, such a simple thing, right? I'm learning from my geography experts and my GIS experts that that's the bread and butter of a lot of the underlying operations that happen. We are able to accelerate it by 10,000, a factor of 10,000, right? And so we talked to our colleagues at Esri, and they say that if you actually have that a level of acceleration because of the architecture, because of GPUs and CUDA, um, things that were not interactive before, things that needed a lot of indexing, uh, can actually become interactive. And so that has a lot of promise in terms of how data scientists, there was a question, should GIS engineers, GIS data experts also think of themselves as data scientists? I think this is one way in which that can accelerate, because they can get instantaneous results of whatever hypothesis they want to test. This is just clustering. Again, it's several orders of magnitude better using this. It's a free library. Anybody can download it. Here are some of the links. Everything we create in terms of the software stack is free for people to use and download. I heard people talking about data sets and the lack of temporal data sets. So I wanted to just add one more point, which is we have for the last 4 years now, including this, been running a challenge called AICT challenge. And it's all about spatial temporal data. The primary source is video, but we have other metadata also that we couple with that. This will be the 4th year. We typically run it at CVPR because our first 300 participating teams all were computer vision teams, but we are getting strong interest from civil engineering and transportation departments too. For those who are actually interested in just looking at this as a spatial temporal data set, I would welcome for you to take a look and reach out to me. Thank you.
Thanks, Milind. Next up to present would be Devaki Raj. She's a CEO and founder of Crowd AI, Forbes 30 under 30 in 2019, Inc.'s 30 under 30 2017. I mean, wow, good. Okay, so she worked on AI for social good projects, former data scientist and part-time product manager. So Google used to be your home, I guess. Okay, welcome.
I have an old computer, so. The HDMI? Yeah, yeah, yeah. All right, give me 1 second. Great. Sorry. Yeah, so my name is Devaki. I run Crowd AI, and what we do at Crowd AI is build computer vision and deep learning technology for any type of imagery and video to help our customers solve their largest operational challenges. So we work with customers across utilities, telecoms, insurance, as well as oil and gas. But what I'm here to talk to you about is a little bit about how we're trying to solve some of the largest operational challenges, and that often occurs after major natural disasters. So I want to talk to you about the work that we do, taking different types of third-party imagery. And as you guys know, in the last 5 years alone, there's been an explosion of different imagery types. Right now, we're talking satellite, but we are also talking about drone. We're talking about aerial providers, and it's not just imagery that it's exploding. There's a lot of satellites that are being launched for things such as AIS. So right now I want to show you a couple of examples of the work that we do in terms of the trajectory we took it as a company to exploit all the different imagery types and then solve large scale challenges. In this case, I'll focus primarily on natural disasters. So we started about 3.5 years ago after graduating from Y Combinator, and that was a time in which Planet just came out with a lot of their satellites. A huge selling point for Planet was primarily, even though the resolution is low, they've got global daily coverage. And so when you think about natural disasters, that's often what you need. You need daily coverage. So when Hurricane Harvey hit, we wanted to do something. So what we did right here is we took planet imagery over Houston, and this is pre-disaster. And then we took the 3-meter resolution data after Hurricane Harvey hit. So you can see that there's extensive amounts of flooding. The reason this is particularly interesting is because often floods, as you guys know, once floods hit, there's two problems when you think about satellite imagery. The first is that there's a lot of clouds, so satellite imagery really doesn't take a lot of the imagery. Satellites can't capture a lot of the images. But two, floods tend to dissipate. Obviously, unfortunately for Houston, the floods didn't dissipate, but there was imagery captured almost kind of within after a day after Hurricane Harvey hit. And so what we did at Crowd AI was use our road detector. So we worked on building a global roads detector on Planet for the last 2 years before Hurricane Harvey hit. So we trained our model in over 126 different countries on Planet. And primarily why we create so much training data sets beforehand is because if a disaster occurs, no matter where it is in the world, we want our models to scale. So what we did was in green, you could see, give me 1 second. What we did was map all the roads on the previous imagery. And then we mapped all the roads on the post-flooded imagery. And then we did a matrix of the two. So the red indicates all the roads that are flooded, and the green indicates all the roads that are still not flooded. What we then did was convert this TIFF file format into GeoJSON vectors and provided this data to first responders. I want to talk to you a little bit more about a different example. So this is on NOAA imagery, and so this is a different resolution. This is about 20 centimeter resolution. And this particular example is the work that we did for a telecoms company. So this telecoms company is the 6th largest telecoms company in the US. They service a lot of different states in the Midwest. They knew that Hurricane Michael was going to be passing over one of the areas that they service. In this case, it's Panama City, Florida. So NOAA imagery is taken obviously by NOAA, and it's aerial footage. So it's underneath clouds generally. And NOAA footage is generally taken over most continental US, kind of US disasters. So what we did was, given that we knew that Hurricane Michael was going to hit, we took past NOAA imagery, created training data so we could have a model that was ready when Hurricane Michael hit. So what we did was, once Hurricane Michael hit, NOAA imagery was actually available a couple days after Panama City, Florida was devastated. And so what we took was all that imagery, we mapped all of the buildings on pre-imagery and then transferred that pre-imagery buildings onto post-imagery and then classified each building based on definitions that this telecoms company wanted. So what we did was we mapped almost 18,000 buildings in a couple of minutes. First getting the building footprint and then providing our customer with locations of buildings as well as addresses of buildings from anywhere in terms of disaster, from roof tile missing all the way through to entire building missing. And what they then did was prioritize where they send their field service folks on the ground. So we see this scaling across, obviously, not only just post-disasters, but have the potentiality to kind of be helpful for disaster management and risk purposes pre-disaster. The thing about Hurricane Michael is actually pretty interesting is if you notice that a lot of the houses along the beach weren't devastated, it was mostly a lot of the inland buildings, which is opposite from what one normally thinks after a hurricane. Got a couple more examples. This example obviously hits more close to home. Obviously, as you guys know, a lot of California is still under a lot of wildfire warning and wildfire is still happening. So we obviously, being a California company, wanted to be able to do something about it. So this is on a different resolution image. This is on Digital Globe. And so we'd worked with Digital Globe for the last 5 years and trained our models in, again, 125 different countries. Again, why we train our models extensively, globally, frequently is because if a disaster occurs, we don't want to wait to train a new model, sorry, to create training data, train a new model and see how it works. So this is the work that we did post Campfire. And so we mapped about 25,000 buildings off of the imagery that Digital Globe had on their open data platform. So this is at 30 centimeter resolution. We mapped all the buildings on pre-imagery over this, sorry, it takes the polygons a while to load. There's 25,000 polygons that are currently loading right now. And then we mapped all the buildings post-fire. And you could see that our models are robust to even nadir angles because we trained our models on different types of nadir angles. And this imagery happened to have a pretty severe nadir angle. And then we identified all the addresses of the houses of the polygons that were no longer visible to the model. And what we're able to do is kind of scale this across an entire county and provide this to first responders. We then take in county information, so these are all parcels, and then kind of classified it by level of damage. So this is all our post-disaster work, and wildfires are particularly interesting because you can't necessarily just aggregate and say this entire area has been destroyed, because if you see individual houses in the same neighborhood, some are standing and then some are completely destroyed. And then one final example of the work that we do is kind of risk mitigation. So as you all know, Santa Rosa fires were fairly devastating in late, I think, 2016, 2017. But this is imagery that's taken on Nearmap a year after all the fires. And you can see that people are starting to rebuild. So at CrowdAI, what we're trying to do is understand, we know that there's a lot of, we know that fires are still continuously going to happen. So how do we speak with the homeowners? How do we speak with the insurance agencies? How do we speak with all the people that do the construction to say, given these risk factors mean that you have a higher risk for wildfire, potentially you're going to build your houses in a different way. So what we did was took the same area that we knew that was devastated by Santa Rosa, mapped out all the building footprints, and then took it one step further, right? So we mapped out burnt trees, healthy trees, utility poles, and also used the CAL FIRE's definitions for zonage around what is a kind of zone 0 through zone 3 wildfire zone, specifically to understand whether people are essentially rebuilding their houses that were lost in a fire in potentially risky manners. And so that's why we want to take this one step further, not just to mitigate risk after a disaster, but mitigate risk potentially before a disaster. So at CrowdAI, we don't just work on natural disaster use cases. Obviously, that's something that's really close to home and really important for us. But the work that we do can extend not only just to kind of nonprofit or emergency response, but across to a lot of commercial customers as well. So if you have any questions, I'm happy to answer them.
Thanks, Devaki. Next up is Jim Stokes. Jim is the VP for Analytics for AI and ML products too at Maxar.
Great, thanks, appreciate it. How's everybody doing? One of these will work. There it is, the regular guy. Good. Okay, yeah, some observations from the edge. So I lead the analytics AI ML product group at Maxar. It's a new group. We are basically a company that's evolved out of a bunch of companies, most prominently, you probably know Digital Globe. Just saw some of our great imagery there being modeled by Crowd AI. But we actually do a lot of work with a lot of other data types too. Most everybody thinks of us as imagery guys, but we do a lot of other stuff. And IoT data plays strong in a lot of different things that we work. We've worked with machine data in agribusiness. So when you look at a combine, it has potentially today, a big John Deere combine has gazillions of points coming off of it, observing observations in the field. We've adapted to an IoT model, legacy sensors like stream gauges that are now connected to the internet. Just go ahead and call it a part of IoT. We can measure a stream volume. Weather data. So we've got a weather analytics team that provides products, and it uses field observations that come from devices in the field that make those detections. And so when we look at this data, we realize, you know, standards are just not really there. We've got a lot of challenges in that space. So, you know, in my perspective, that's a place especially that could use some thought leadership and guidance from a standards community. You know, the data a lot of times a little different from imagery data. These observations are small, but the volume is huge. So it presents a different set of challenges in dealing with that data. And in many cases, it's also very high velocity. And with that high volume. And it represents an extremely great opportunity to be able to change the paradigm of analytics to be more focused on that edge. But at the same time, that volume creates data engineering challenges. And many of my colleagues have addressed a lot of these different observations and different perspectives. But from my standpoint, that data transaction, and I really liked what you had presented about that gap between the edge and then the cloud. We have to have both, and how we bridge that gap is really important. And we've had to build a lot of different things to make that gap filled in because they just don't exist, right? So we're living in a world where all of this stuff is very much like Philippe said, we're so early. This is baby. Our AI is of baby mind capability, right? AI right now is just tools, right? When you really think about machine learning and the other components, they're just tools really to kind of help us. So these technologies, you know, really standards are important. One of the big things we also observe in the data and the normalization issue is the time factor. So I wasn't around maybe for some early conversation earlier in the day around temporal, but we see time as one of the critical elements that comes through to be able to normalize a lot of these and then make key observations that are extremely important from that data. So we've actually been kicking around some concepts and written up a couple white papers on the aspect of a time information system, much like a GIS, geographic information system, an actual platform and a methodology for dealing with those temporal data sets by presenting standards and methods. And I think that would be something from our perspective that could be great in an open source world to have the world kind of pile in on ways of normalizing across time. Pedigree is critical. We see tremendous amount of spoofing, especially in like mobile device data that's used for LBS. You know, a lot of people get paid by the unit, so they come up with ways to add more units to their pie. And if you're not able to detect where that observation came from, then you're going to get paid for that. So spoofing is a big problem. A lot of fake data generated that we see. And then you can't even trust the device necessarily, right? the device, depending on its own pedigree, may be throwing off some sort of errant data or data that's just not right based on it's trying to make the performance spec. I mean, we all saw what happened with VW, right? I mean, reputable companies still do things that they probably shouldn't do. And you can't just trust the chip. You can't just trust it, right? So you have to be sure that you think through where all those different pedigree aspects can come in terms of the data. Privacy, you know, big deal, right? When we're looking at a lot of things that we can do with device data that comes from these, it's really important that it's used for good. We're able to discover a lot of patterns in an anonymized way and use that location data to help us understand other things or better ways to use our satellite constellation or new models. But the real key is really to deal with that privacy in such a way. And I think that's one of our roadblocks, along with policy and governance, more so than even the tech, right? The tech can get us there. It's those aspects of that privacy, governance, and otherwise that are going to be an issue. And this last point here is for us, you know, we work with satellite imagery, and one of our big paradigms is there's not enough eyeballs to look at the images to understand what's in the images. So we need the machine to make life and data easy for us. That's the value proposition of potentially using machine learning to pull features or automatically detect objects in imagery. But really, there's other novel and unique ways to use the tool, right? And back to the point of it being a tool, you know, using machine learning methods as a filter to help feed the analyst. Having been an analyst most of my career, having learned from a guy who was a senior in US government, who was an all source analyst and had a slogan on the back of his card that said, "What part of all don't you understand?" And we talked about all data earlier. You know, I argue that we need to yearn for the best data, not all the data, right? So let's use the machine learning as that tool in the process, put it at the edge, figure out ways in the near term to deploy that tool. I think that's one of the big things we've observed in our, you know, artificial intelligence strategy from a product team is that what can we do now, right? And maybe I come to the table with that little disruptive thought of we've had a lot of discussions about big things and different things, but how do we use the tool now to help get the most out of these different voluminous content that just present these daily challenges? So that's my perspective, and thanks for having me.
As I plug it in, maybe the panelists can come up here. So the way we're going to do this is I have a few questions that I'm going to put up on the screen, and we'll have the panelists make their comments about it. And then after we finish a few questions, we'll open it up for everyone to ask. So just think of these as just to get the conversation going. So the first one is, what is the future of AI as we head into 2020? What key problems will be addressed in 2020? Which ones will linger around and prevent adoption by the data science community and organizations at large, accepting it as a mainstream aspect? Will it be ethics, governance, explainability, or just the fear of the unknowns, which is sort of like cropping up to the top quite often in terms of this adoption? That'll factor in as the thing that slows down the pace of AI infusion into everything that we do in data science. So, Anand, you want to take that?
Yeah, so short answer is all of those. If you press me for a specific answer, what I'll say is the biggest challenge is lack of data. I mean, there are companies today built for data. They have a natural advantage. There are other companies that have deep enough pockets, they can acquire the data that they need to uh, make progress in AI. And there are small companies who, I mean, Devaki's is one she talked about. They're actually very nice applications, niche applications, razor sharp focused. They identify a problem that's helpful to solve, and they know how to do it, right? But there is a big ecosystem in the middle, right? So there are companies that are small enough, their data set is not big enough to make decisions with confidence. There are cities, municipalities. I was in a discussion in the Schulich School of Business in Canada, and I happened to sit next to 2 or 3 city administrators, and they were talking about it. What it felt to me is like their respective towns. They were all pretty close to each other, similar socioeconomic structures and so on, but their respective towns don't have enough critical mass and data, but together they might.
Mhm.
So what might happen is we are going to see a little bit of ecosystems evolving by compulsion, and may not be strategic. That may not have been chosen, but that's the only way they can get enough data to make decisions, right? The another example is collaboration between companies. Yesterday, there was a news bit about Toyota collaborating with the Japanese weather department to provide Viper data,
Wow.
right? So this is not something that happened by this thing. Suddenly, somebody identified a mutually beneficial opportunity. They went with it. So we should expect conglomerates forming across companies in other is insurance and health industry, right? So there may be collaborations that we don't anticipate today. That's going to be the next step to watch.
So look out for unusual collaborations.
Exactly.
Anyone else want to comment on this?
So what I would, yeah, so what I would say is there are some real good successes that AI has enjoyed, right? And I mean, when we talk about AI, this is really something that's going to transform for decades. It's not, at the risk of saying this question is, very short-sighted.
Yeah.
It is very short-sighted. We are going through a totally different paradigm of what computation means. What AI means in terms of workflows changing and so on and so forth. So we are not. I would say we are in the first innings, right? And I don't know if it's if we are just seeing the first base, right? So there are already notable successes. For example, conversational AI is doing really well, right? You see more and more. Most of my iPhone answers WhatsApp messages and SMSs by itself. I don't even seem to be driving the response to an SMS that I get. Apple already suggests that for me.
So if you get something from you, take it with a pinch of salt. It's not the real Millen.
So yeah, I mean, there's always the plausible deniability, right? Hey, that's Apple's AI, that's not me. So conversational AI is doing well. I think the vision part of it, right? Computer vision part of it has found very good niche applications. Self-driving will happen. It will take time. It will happen. But I think that the main thrust that at least I personally will push for in 2020. So that's what I can answer. There are a lot of what I would say hello world experiments, and we need real world solutions, right? And so pushing a lot of these experiments into real production, into real operational deployments, is where I think more and more of us will see our thrust being, and that will bring with it its own share of pain points, which have nothing to do with the algorithm or the actual science. It's just the core engineering of building end-to-end systems. And so far, we have nicely segregated ourselves into I'm a data scientist, I'm a data engineer, and whatever, right? But at the end, a city or a retailer or a municipality will want an outcome. So I think we have to start gearing towards those outcomes. And to that end, benchmarks, data sets with labels, these things actually really keep us honest. So each of us, in whatever way we can, should be contributing towards creating these benchmark data sets. So the end users can actually start having confidence that this really works. And I'll give you an example. There are DOTs. I'm sure there's somebody here from Department of Transportation. They have a big fight with us, saying, radar is it? We don't trust cameras to do as good in terms of vehicle counting. Radar is it, right? And so it took us years to actually prove to them that camera-based vehicle counting is as accurate as they need to be for making decisions, right? That was something that had to be proven.
Right.
The assumption was that it doesn't work till you prove it otherwise.
Anyone else? Okay. Thank you. So let's move on to the next one, which is how far will hardware play a role in propagating data science and AI to be an integral part of everyday life? What are some limitations and challenges today which we feel that should be addressed or being addressed? Is the next generation of applications poised to benefit from these advancements? So Milind, I mean, you come up with new hardware, right? A lot of software doesn't run on it, Anyway.
So I would say that that's why I knew you were going to ask this question. That's why I brought that OpenAI chart with me, which says that we are really expecting a doubling in computing need every 3.5 months. So forget Moore's law, right? So we do need to go beyond that architecture. We do need architectural advances, which we are seeing. But it's not just hardware, because if you notice, for example, I only speak on behalf of NVIDIA. On top of that GPU, the computing architecture is a stack called CUDA, right? And that's what makes any code developed by an application developer work against any of our hardware, right? So as much as hardware getting better and the software above it getting better is concerned, which is going to happen, the fact that for an end user, or in this case a data scientist or a data engineer, being able to write one piece of code and having it work everywhere is actually vitally important, and that's what will actually help in pushing the next phase of benefits from the application.
Is NVIDIA working with universities to increase the academic environments, churning out of CUDA programmers?
Absolutely. So we have what we call DLI, Deep Learning Institute. We have a lot of initiatives where some of these courses are offered completely free of cost and online. And actually, we have an extremely strong partnership program with universities. So a colleague of mine keeps the statistics on how many more developers are now DLI certified and all that. So we actually do believe that uh, this this part of curriculum will actually now become pervasive, and I'm seeing this happening. It's not even PhD students anymore. Even my kids now want to go and buy a Jetson Nano and use it to program and write code to figure out if there was a cat. There it is, right? Thank you. To figure out if if a cat was in our backyard in the night and did something, right? So I think the overall I think we are pushing this knowledge and pushing this learning into earlier and earlier stages of the education cycle, which to me, you were saying about learning from interns. I'm pretty sure I'm going to learn from my kids by the time, they are in college, more than what I can teach them.
I thought they already knew.
Yeah, they know it all already. And, Raspberry Pi, or, a simpler version of that. I think on this, it's like, it depends. It's like, okay, there's some hardware challenges and issues that we still need to get better at certain things, but we found that these things on the edge can be simpler, right? And the fact that we've been able to actually maybe take a step back, it becomes more of an architecture and an application set of requirements that really drive how that distribution of that hardware, and in some cases, thing, it's back to the future, right? We've gone through these different phases where it's like back to client server, all these different aspects of how we get there. So right now, I think we're in this mode of having to even simplify on the hardware side with these devices to just get the simplest form of the data and the content. You've got a comms and a network challenge that's maybe the thing that you don't need to simplify, but mesh networks are coming. Mesh networks with SATCOM are coming. That changes all this paradigm of the aspect of the edge, right? And then there've been things around called FPGAs associated with CPU. No offense to my GPU buddies over here, but they've been around for a long time that can do a lot of things. We're just not taking advantage necessarily, right? So I think that there's parts of hardware that actually were way ahead and still haven't even been exploited to their fullest years and years later. But there's still some gaps on communications, really the big data piece, performance. That's most of my thoughts.
Yeah, and to that part, I think a lot of the productionization right now for people to really productionize the data or productionize the output of the AI, they are fairly savvy in terms of what hardware plays a role in that. So some of our customers, specifically on the humanitarian and disaster response side, for example, we do wildfire detection in real time off of drones. They said if it doesn't run on a P100 at 15 frames per second, they can't really productionize it. So right now, a lot of it is kind of also, it kind of drove our research, the hardware constraints, as well as obviously the customer specs drove our constraints in terms of how we build AI models. And that potentially will continue to happen as hardware plays a large role in kind of defining productionization requirements, especially on part of the AI.
Cool. Thank you. So the next one is, what's the most meaningful and satisfying project you've been involved in? Applying data science, both the principles and the practices, and why did you find it fulfilling?
Well, I'll start given most of my talk was on natural disaster response. So for us, being a California company, obviously wildfires is top of mind. I mean, if you're in San Francisco or Oakland, just last week you could see the smoke coming from the fires. So for us, it's being able to use AI to solve some of the most fundamental challenges that humanity will face going forward. It's not. I mean, obviously we want to both as a company do good, but also do well from a financials perspective. So it feels really good to have the ability to apply AI to solve these problems. Also attracts great talent, right? People want to know that the work that they're doing actually solves important problems. And so for us, it's a win-win. Not only are we doing good, we attract and retain incredible talent, but also it's kind of where the future is going.
There's been a number of them, but the one that is most gratifying is we used machine learning to understand how people move in a city and what modalities they use, and then we actually married that to the existing public transit infrastructure that they had, and we found out that there was this one city where people just kept dragging the bus route to the point where end-to-end the end-to-end time to go from the one end of the route to another was 75 minutes. Frequency was once every 2 hours, and the city was losing money, the state was losing money, and the federal money they were putting in. It was just a really terrible situation. And because service was low, utilization was even lower, and it was just a death spiral. And just based on data, we actually completely re-optimized their transit. And now we see that it's very successful. The occupancy, the ridership has gone up 37%. End-to-end journey time has gone down by 40%, and fuel utilization has also reduced by 38%. So I worked on many more complex projects, but this is the most gratifying because when you see what data science can do and change an outcome for a city, which is now not having to cut the subsidized bus service, right? Which actually affects their neediest people the most. So
I'm going to cheat a bit and answer a slightly different question. So I have what I call the envy list of projects I wish I was involved in and I haven't been involved in. Last week, there is a story from NPR about African elephants, savanna elephants. Did anyone read it? Okay, I'm going to tell you the story. It's very quickly. It's
This is storytelling time.
yeah,
It's data
exactly.
science
Yeah,
time.
yeah. Right. It's they were trying to do a census of African elephants. Their perception is it is going down, but they wanted to be sure statistics wise. I mean, they started the most obvious way. I mean, all the they used aerial photography and tried to count the elephants. It didn't work because elephants like to hide. They live in the forest, and it is hard to be sure that they got all the elephants. So what they did was to plant microphones all over the thing and try to get a network and use statistics to try and extrapolate for the rest of the jungle. And they heard something that they didn't expect to hear: gunshots, right? So they retrained the model to detect gunshots and trigger a proactive activation system. And they were able to prove that that actually cut the decline and turn the curve around. So I hope to say before I retire that I was involved in one such project. I don't know what it is yet.
Very inspiring. So next one is, what's your opinion? What, in your opinion, is the biggest challenge we face in the world today, which can be answered with, if you had to pick one, data science, AI, and some trend. And just for some hints, it could be quantum computing, blockchain. Uh, I had to put it up there. Edge computing, 5G. So you know my opinion about it.
Only pick one of the
Oh,
technologies?
no, you can pick all also. I mean, if you can talk to all of them, great. Yeah.
I like big challenges. So apparently it's the biggest challenge in the world. That's a pretty big challenge. To me, I think where my heart on this is the convergence of environmental impact of population expansion, right? And I think our world, with the combination of all of these technologies in a lot of what we've been talking about here today, being able to have model integration, data that is high velocity, um, sharing and collaborating across those models such that AI is more learning on the results of the first phase models to the point that we make discoveries so that we can actually mitigate the problem, right? We can get predictive and prescriptive on that value chain. Philippe used a classic on that value chain. So to me, I think there definitely is a finite set of resources. I think we'd all agree on that. We'd also agree that the population is booming out of our control, right? And being able to help solve those challenges, I think the pieces are there to be able to do that. The observable engines and tools and sensors are there to do that. We're just not at the point to put it all together. And again, I think it's all these things that eventually come together. I think we live in a day and a time that's amazing, though. You think about the fact that we can do almost lab coat level research and use frameworks and modern computing techniques and access the data that comes from the remote places in the world and even the universe and turn that into a usable product for many people in very short period of time. That's just transformational. So I think when these things start to come together in model integration and other ways to kind of have the community be able to share that across standards, we'll be able to start to tackle that challenge. That's my take.
There are so many, right? So one would be hard to pick, but if there is one that actually has a pervasive impact on many fields, I would say, with the help of these technologies and their conversions, if we can scale expertise, right? We have very few really good doctors in the world, but we have 7 billion people needing that. We have very few really good teachers in the world, but we have the entire student community needing that. We have a lot of food that gets wasted, and then a lot of people that don't get food. So that's more of a supply demand. So I think ways of meeting demand, to the population that we are growing to, with the resources that we have, without without destroying our ecosystem. That's where I think.
So it's like a sustainability of human existence. It's a
Yes,
fundamental.
yes, that's what I think.
That's a great answer.
I just wanted to say concur. It's a great answer.
Yeah. Any suggestions for introducing a field of geospatial data scientists? We know data scientists exist. We know geospatial analysts exist. What about geospatial data scientists explicitly? Firstly, is it necessary? And then, it's both to recognize the trend as well as, it's to increase the number of practitioners. Any comments on that?
Yeah, to be honest with you, we started saying that years ago. We actually, when data science came on it, we said, well, we're geospatial data scientists. When the data science trends started coming, geo is hard, by the way. It adds a level of complexity that's way harder than people realize. And when you go through the generic course of data science, you're not even close yet, right? And so I think it is a field that needs specific components of education and training. There's nuance, and beyond the nuance, then there's big rocks behind that. There's an iceberg behind geospatial data to actually get the true value out of it. And so to me, this is a big, I'm passionate about this one. It's really important that there is an education and field of study around data science that's focused on geospatial. We'd all benefit from it.
Yeah, so I think geospatial analysts are domain experts. And I think that data scientists tend to sit more horizontal across it. I think the way we can marry the two better is because, you don't see data scientists necessarily learning geospatial technology, but you expect geospatial technologists to learn data science. So how do you make sure that they could do both while still remaining domain experts? So I think there needs to be kind of a meeting in the middle of the two, which is you have geospatial scientists that are armed with tools that data scientists build that are geospatial specific, so they could meet them halfway, right? I want to make sure that domain expertise remains still domain expertise without having to kind of water that down because you wanted them to do so many things. I don't know exactly how that works or how that would be implemented in the real world, but I think the value of having geospatial scientists is because they're really good at what they do, and so you can't really water that down by asking them to do all these other things.
So you're saying it's a team of two and not one person who expands into some of the newer techniques of data science?
Yeah, I think that, or potentially data science tools become more flexible for people that have domain expertise. So even bringing down kind of the researchy elements of data science and something that's more tangible for geospatial analysts.
So who's feeding into whom? I guess
I
is
don't
the other
know.
question,
I don't
right?
know. I'm not being prescriptive about how it should be done. I'm more kind of
Okay.
opining on it.
Yeah, two parts to the answer. One is yes, like to your point, you don't want to lose one expertise at the expense of another, and wait till the geospatial guy who also learns TensorFlow find out like TensorFlow pays like 3 times more money, so he's going to switch to optimizing website clicks, and where does it leave us, right? So, the second part of the answer is that is slightly flippant. The second part of the answer is I'm not saying this is widespread, but some universities already do that. I was talking to some placement people. They in Waterloo, they run a co-op program. The co-op coordinator happened to be from the Department of Environmental Sciences. So they have a program in what they call geomatics. That's a cross-disciplinary thing. So they're allowed to take courses from 3 different departments: engineering, mathematics, which is the computer science as well, and environmental sciences. So I think they have very little mandatory content in their course. It's pretty much what makes you happy to get them and just get the right number of credits using whatever combination. I haven't really explored that much in the sense like I don't know what people do after they graduate and stuff. That's something for me I want to find out. And I think that would be a good model if you. I mean, I don't know how many universities do something comparable, but that's for me it is a relatively recent discovery.
Okay. Yep. We'll open up for questions for the panel. Anyone with the question? Oh,
May I answer the last question? I am an academic. There are at least 50 programs like that here in the United States. I'm from one of them. And arguably, I would say the most successful ones are over there in Europe. Because they have they are less afraid of reaching out into information science. So there are lots of geo programs that are now de facto geoscience, geoinformatics programs over there.
yep. Thank you.
The only thing there's this extra piece kind of on in addition to, I totally agree that no one, we were talking about it at our table, no one can know everything, right? So if that expectation is ridiculous, and people have to have their area of expertise. But there are, and it's one thing that it's kind of interesting we haven't really talked about much, but there's machine learning and AI, and for the most part, we're talking about taking kind of traditional ML and AI and applying it to spatial data. But there are inherently genetically spatial methods that are exclusively that take geography into account. I mean, Ed started by saying that things that are closer together are more related than things that are farther apart. It like invalidates lots of statistics right off the bat. And we're not thinking about spatial in the way we develop machine learning algorithms in the way, because those data science programs themselves aren't spatial. So it's not so much about GIS, geospatial analysts becoming data scientists, but it's like we need some spatial injected into some of those computer science, statistics, data science programs also. Sorry, it's not a question, but I'm also quite passionate about this topic.
Yeah, I agree with that. I think you make a good point. We want the geospatial analysts to stay domain specific, and there are geospatial analysts that then are subdomain specific within that. We're talking about more of a much more technical developer type role that takes on a data science type career. It's a different persona in the grand scheme than the geospatial analyst, in my opinion. So that's just my observation on that one. Yeah.
I'll just add to that. The person who really helped us develop the QSpatial library actually started out as a GIS expert with his PhD in GIS. He's a professor at Jianting Zhang. He's professor at City College, New York. But then over a period of time, since things were not as dynamically interesting in that domain, he trained himself on CUDA 8 years ago, 10 years ago. And he actually had been working on GPU acceleration of some of the spatial operations. And when we decided we really needed this in the Metropolis platform, I reached out to him. He just came in and he helped us build this whole thing. So we actually cheated. We benefited from somebody who was a GIS expert who also over his career became a GPU programming expert, right? And now the benefit of that is not everybody has to go through that. And GIS experts can now just use this tool, right? But that kind of tooling, and to Devaki's point of that kind of tooling will need to happen. And that can only happen when the first phase of, let's all do click through gets over and people start looking at other problems to be solved.
Yeah, the reason why I put up this question was during a user conference that we had earlier this year. There was a user who came and asked something along the lines of, GIS Analyst was created over the past, 10, 15, 20 years. And there's a pay scale that's associated. Python developers are there at a pay scale. Data scientists are coming at a different pay scale. I want to see my career grow. I went and spoke to them. I said, I learned Python. I'm a GIS analyst. They said, You can either choose JS Analyst pay scale or the Python developers pay scale. What they were asking for is, I provide much more value than either of these in isolation. I provide the value of a data scientist who can give you the answers, the solution, the outcomes. But just because I predated this trend, would I have to be left behind? So that's actually the reason why I'm bringing this up, that we not only have an obligation to make everything correct and perfect in terms of the boundaries that we build, but also in terms of making careers out of people who can deliver the outcomes. So that's the origin. I mean, I'm just stating this as this little beyond the conversation that we have. So just consider that. Yeah, question there.
So I was just going to add a comment that, it's a hopeful sign in any field when we get enough depth that we actually have to start to specialize. So the same thing happened to medicine. You can't be a specialist in everything. It's a good thing that we're at this crossroads. But I wonder if this is the right question. Really, so I'm also a professor at UCLA, and I teach my data scientists how to work on interdisciplinary teams. So I want them to be respectful and understanding of the scope that storytellers bring and what geospatial experts bring and what policymakers bring, rather than make any one of them feel that they have to be all things to all people. As long as they're conversant with each other and able to come up with the whole thing, it's very rare that we need that one superstar. There was a Leonardo da Vinci, but there are a lot of other inventors after him.
Yep, great point.
I think there was a paper published recently, or not recently, but talking about how autonomous vehicle algorithms were manipulated by stickers pasted on stop signs, right? So I'm just wondering, for geospatial data, is there a certain part of the industry that has a better position to actively monitor and prevent bad actors or bad data into seeping into the models and changing them?
That's you. I don't think there's necessarily a part of the industry. It's unfortunate that we all have to bear the burden of the cost associated with combating all these different cyber challenges. It drives the cost up in the grand scheme for all of us. And with your requisite model or data type in your industry or sector, you have to focus on what those vulnerabilities are. We suffer it with satellite imagery in a lot of different ways. It's not only the data, but we've got gazillion-dollar machines in space, right? And that's a whole nother thing related to ensuring the integrity from a picture in space to the ground to then all the next things that happen, right? And we have to take care of that all ourselves. So unfortunately, it is on the onus of the operator of whatever that model, content, element, and then the autonomous car systems and the providers of those are going to have to deal with that themselves or wrangle it out between source content having a pedigree, and that company has to certify it and insure it. So it's at each one of the source levels, if you will. Yeah. That's a mic drop. Thanks.
One more question, maybe. Make it a good one.
Have any of you worked on any projects with interconnected infrastructure, wastewater, drinking water, electricity, gas, natural gas, petroleum, any projects like that?
Yeah, I have. So networks, let's say electric power infrastructure networks. So what would be your question then?
So interconnectedness of this resource. So for example, if you have a wastewater treatment plant that's using SCADA and the internet goes down, or there's no cell service, or if you're looking at power generation, people think that if the electricity goes off, that's a bad thing, and it is, but they don't realize that if the natural gas isn't powering the electric generation station, there's no electricity. So natural
Right.
gas is very important. If there's no water, there's no
Yep.
electrical generation either. So any projects where you've worked with any local agencies where you're trying to understand the interconnectivity of the infrastructure, and especially for emergency response and recovery is where it comes into play most.
So that's a big concern across a lot of different angles. The first thing that comes to my mind are my colleagues from Esri and fundamental to GIS, right? And especially, putting together multiple networks and being able to understand where a portion of that network fail, what's the downstream effects, and they fundamentally have technology that can cascade model effects and all those things built into that. It's a lot of work to build a network, but once it's there, it can be smart and intelligent, and you can do interdependencies. But I'll defer to Esri to respond.
You answered. I mean, I think you're familiar that we have the utility networks for, we are also going through a major overhaul and redesign, and we've shipped some new parts of it, which is everything is service-based, as opposed to you have to work directly with the database in the client-server model. And the idea there is you can go disconnected with one of these and still make it effective. That's where I think the first generation of going disconnected happened between, let's say, the servers and the actual devices, the field devices. So it was a person going disconnected who didn't have the, data availability because of the network, right? I meant the wireless network. So they went disconnected. I think we are seeing the next generation of that happening, which is between machines going disconnected, which is what the edge we were discussing earlier, that you still have a system of truth that is in the center, but then you're able to disseminate that to all the edges. So let's say in this case where the internet goes down or power goes down in different places, everyone has the last known truth or the last known system of record to still sort of like have emergency operations run. So it's not just the device that's going to have that, but even a utility network. And then the interconnectivity is like what you said, the gas lines and the electric lines and everything else, layered one on top of each other. I mean, right now we're going through a phase where, yes, it's still individual. They're not heavily interconnected, but you can see that happening more and more. So thank you, panel. Great discussions. We can do a check next year whether it was all.
Thank you, Jay. So two last things. We've worked very hard today, and so the reward for that is a reception. So please come over to Stein's Beer Garden. It's right off of Castro in downtown Mountain View, and join the folks there. And then we'll be back here 8:30 again, check in tomorrow morning, 9 o'clock, and we'll start talking about applications and next steps. So thank you all for today, and we'll see you tomorrow or tonight.